Hello, it's Duncan. Here on Team Gilded Rose, we are still refactoring our error handling. So what we had was exceptions, and we still have a lot of exceptions that are thrown by our item loading code. But the one right at the bottom, when we can't build an item because we pass a negative quality, we're now representing as an error type, where one side of the error type is an item, success, and the other type is nothing, question mark, which is the type of null. So basically, we're still using nullable item, but we're using Result4k error type to migrate to something better than null in the case of errors. And our reason for not just wanting to use null is that null can't tell us what went wrong, only that something went wrong. At the moment, of course, there's only one thing that could go wrong, which is negative quality. So I think what we're going to do is we're going to add another thing that could go wrong. So let's put that in here, duplicate this, and we're going to say require name is not blank. Can't have a blank name. Now we should add a test to that. So let's go to our item tests. And at the moment, I think we test it somewhere, which is cannot create an item with negative quality. So we'll just duplicate that. And this is cannot create an item with blank name. So that if we would try to create an item with a blank string, but still some quality, then we'd expect a failure. Let's run that. Okay, right on cue, we have a new version of the Kotlin plugin, but I think maybe we'll leave that. And here we were just testing the code that we put in here, because you can see here, any exceptions we catch and we return a failure. Okay, we're only actually throwing one type of exception. That's the type that's behind require, which is an illegal argument exception. What we'd like to do is have different error types rather than null here. So I think we're going to go down the bottom here and we're going to create ourselves an error type. And these days we can have sealed interfaces, which is probably a good place to start. And we'll give this the name of item creation error. And we now know that we have two of these. One is a class, and we're going to call it negative quality. And it might be helpful to know what the actual quality that was passed in is. So we'll give ourselves a val actual, and that will be an int. And this wants to be our item creation error. And let's make it a data class so that we can compare them if we need to. Now, the other type of thing that can go wrong is that we could have a blank name. And all blank names are the same. They're all blank. I guess technically they could have spaces in them, but let's just go with an object to represent blank name. And that's going to be an item creation error as well. And the point of using a sealed interface here is that by inheriting from a sealed type, anyone that processes an item creation error will know all of the types that it could be. So they can put it in a when expression and that sort of thing. Okay, let's go back to our tests. What we'd like here is that this would be a failure of item creation error blank name. And that this would be a failure of item creation error negative quality. And the negative quality that we expect to see is -1. Let's put that in there. If we run that, it should fail. And does as we expect. Note that because the return type here was nothing question mark, anything is compatible with that, which means that we can use a concrete type in here, which is quite a nice feature. Okay, let's go and see how we can make this test pass. Now, we could ask before here, we could remake these checks before we call the constructor an item. But it would be nice to be able to reuse this code so that we were using the same checks, whether we run through the init method or run through this invoke. And that way we'd have the same checks when we call the copy method if we ever did. How can we do that? Well, a nice little trick is to make these things exceptions. So this was an exception, and this was an exception. This is only sort of transitionary, but if we do that, and then we inline these, then we can throw the actual thing that we want rather than our illegal argument exception. So in this case, we want to throw our item creation error negative quality, passing it the quality. And in this case, we want to throw our item creation error blank name, just that object. Don't need these strings anymore. And we can simplify these expressions. Having done that, at this point, we can catch the exception that's thrown from the init. So we call it here, catch it here. In here, we can say if our X is an item creation error, then we can throw it. And otherwise, well, that's unexpected because the only things we think can be thrown by this constructor are these item creation errors. So is it possible that type4 would fail? And in that case, that is an error because we don't expect that to happen. So that's a programmer error, and we should express that as this whatever happens from error, which I think is a legal state exception. There we are. So that's an unexpected. If we start seeing these crop up in production, then we know we've messed up. And talking of messed up, we don't want to throw, we want to return a failure here with the X inside it. Okay. Now this doesn't compile because we are not now returning the right thing. So let's replace this with item creation error. Here then, we're now returning a result with an item creation error, but we want to return a result with a null. And we can do that with map failure, returning this null. That will change the type of the return here. And that passes our test, which is nice. Just going to remember what we've done. So we went to item. We have added another way that this can fail. We've represented the way that it can fail with subtypes of a sealed interface. And we've thrown those types, we've made them exceptions, and we've thrown them here, caught them here, and then we are putting them inside a failure when things go wrong. So the type of this is a result of either an item or item creation error. And then dealing with that, well, we can either, as the tests do, actually see that that's what we've got, a failure with one of these two things, or at the moment in persisting, we can take that result, the failure type, and map it into something else. That's obviously only transitional, but let's just check that in. So we've got a checkpoint. Use result item creation error. I think maybe we'll say start using. Okay, good. Now, obviously, we took pains to add details of the failure into the result type, but we just lost it here. So obviously, we want to do better than that. So let's go up a level. And let's take our item creation error, so remember the type. And in here, let's allow that out of here and see what happens. So we now no longer need to map the failure. And that should break code just above us. But interestingly, it doesn't. Why is that? Well, the answer is here, we're just saying on failure. I think that previously this could have said return it, which would have been the type inside there. But now it can't. But that doesn't really matter. Let's back that out. I think we'll leave this bit alone for now and go looking for other ways this could fail. Okay. First place it's obvious is here, this IO exception. We're actually throwing an IO exception ourselves there. What should we do about that? Well, Result4k has a trick up its sleeve here, and we can say result from on any block. And if we do, then the type that we get is a result of whatever this expression is, the expression inside the whole block here, and any exception that's caught. And on the other end, we can say, or throw. So that allows us to parcel up exceptions inside a result type and move them from one place to another. And you can see our test still pass, and our test still pass despite the fact that somewhere in persistence tests, I think, we actually do have this test here that shows that this piece of text here came out of here. Now we're trying to avoid creating throwing catching exceptions. So what we'll do is we'll move that pane up again. So we take this out and say, what is the type of this? Then it is a result of an incident or exception, all of which may be null because we may not have had any of this. It's a little bit odd. We'll fix it in a minute. But we can take this code here, I think. Maybe if we take this and make it a variable, and we'll call it last modified, which appears to be none of the options, then we can all throw here. But we only want to do that if we didn't get a null back. Okay, we're certainly not done, but we're beginning to push these exceptions out so that more and more of our code is just returning values rather than throwing exceptions. We would rather, of course, that this code here to stock list was able to communicate why it went wrong in a way that wasn't throwing exceptions, but at the moment it has two things. It can throw an exception from here, or other bits of code, or it can return a result with null inside it to say that it couldn't work. Two ways of doing it. So as we did with item, we're going to try and find a type that expresses what went wrong. Now, we could add things to item creation error. These are currently in the same compilation unit. This is a sealed interface. We could add to it anywhere. But it feels like the ways in which creating an item can fail are different than the ways that loading items fail. Obviously, there's some overlap, but we probably shouldn't intermingle those things. So we're going to create ourselves a type at this level to express what can go wrong with loading a stock list. Put that down the bottom, and we'll call it stock list loading error. Now we already know one of those errors, and that is couldn't parse last modified. What do we want to put in here? Well, maybe I think the message from the exception. That's a good start if we don't have any better ideas. And we'll make this a data class, and we will make it a stock list loading error. Now, previously we've worked from the bottom up, but now I think we'll work from the sort of middle out, and we'll say that what we actually want is for this to stock list to have that as its error type. And if that's true there, that's also true there. Now, we have a problem here because now we can't put null. We don't have a null to use for stock list loading error. So I think for now, what we're going to do is we're going to just add ourselves an object for other ways which has failed, which is also a stock list loading error. And then we'll be able to take that and use it here. That makes the types work. It should probably be the callers of this, or in fact, this and this now don't compile, so let's just have a look. But it turns out I'm wrong. And that again will be because the type here, we're just calling on failure. And that doesn't mind what the type of the error was. Okay, going back. what we would like to do is to fix, I think, this or throw now. So if this fails, we want to return a failure. Thing inside that will be stock list loading error dot couldn't pass last modified. And we said that we could take the exceptions message. Reformat that so we can see what the problem is. Get rid of that, and this dot reasons dot message, which may be null. So we're back to saying, let's see how that does for us. Okay, so now, because we weren't actually throwing, our test here fails because we didn't throw. What we did actually do was return an error type, which after all was the point. So now instead of trying and catching, we can just assert equals in here. So we can say assert equals. The question is, what do you get when you do this? And the answer is a failure. And that failure will contain stock list loading error, couldn't pass last modified. And the text inside that should be the text that we had before. Let us see whether we're right. And we are. So we have this pattern of changing from somewhere where we have to create a block in which we can catch exceptions to just looking at the return value from something. Okay, good. Let's go back and look in persisting. We're still throwing and catching. In fact, we're doing it twice because this is throwing, we're catching, this is throwing, and then we are catching in the result from. So let's cut out that middleman. We could inline this. And here, instead of returning a failure with the exception inside it, what we want is our and push that into here. And now we can cut out two middlemen, putting that into there. Mess that up a bit. And we know that this should be our date time parsing exception. Well, I think you may get the gist of what we did there. We don't have a lot of choice here, but to catch exceptions from this, because we don't have a way of parsing that can tell us it failed in any way but exceptions. But now we're not throwing an I exception as an intermediary. Here, well, we are now back to, you've changed the type of this, there. And I think probably inside here, an import would be good. And now we're back to compiling and parsing. So a little warning there somewhere. Oh, we have an unused import. This failure is the failure that's inside here. We don't have to create another one. So on failure, return it. That's not our normal sort of way of dealing with these, but again, we'll leave it like this for now until we can see a pattern. Let's crack on and have a look at this other. So this at the moment comes from failing to create an item. And you remember that the types of that can be this item creation error. Now, a nice pattern here is to just wrap one error type in another. So we'll come back here and we'll say that what we have is a failure to create an item. Why? Well, that is one of our item creation errors. And this is going to be a stock list loading error. So now here, rather than just returning other, when we get a failure with the item, we can return a stock list loading error, couldn't create item, giving it what was inside our initial failure. A little bit of import there. And I suspect that we need to say a reason there. Okay. So now we've not lost the information about what went wrong. Inside other, we have actually a type here that marshals it for us. Just check that it does actually run, and then we'll add some tests to show that we're using that code. Okay, it does. Let's have a look in persistence tests. So what we want to do here is to see what happens when these things go wrong. Here we were saying with a blank class modified header, we could say it fails with a blank class modified header, and let's add in some tests for other things that could fail. Now, how do we arrange for these things to fail? Well, the easiest way is to just put in a string that's a bit wonky. We know we had a tab separated string. So let's see if we can build one of those. So we're going to parse something as a stock list. And the thing we're going to parse is something that is a banana and then has a tab and has some sort of date and a tab and then some sort of quality. And we're going to use -1 to make it fail. And then we've got fails load with negative quality. And we want this to fail with something. And we had our stock list loading error, couldn't create item, which in turn has inside it a item creation error, negative quality. And the value inside that is a -1. So, well, there's a chance that we get that right. I think we probably import this on before we go on so we can see it. And apparently we did get it right. So that's fails to load negative quality. And we could check that this was right by just changing, make the test fail and see how it fails. There we are, that did fail. And the reason it failed is that the type inside the failure was slightly wrong. Well, that's quite pleasing. So let's just return that. And then we could duplicate this test. Fails to load with blank name. I think with looks nice, so we put it back in there. So now if we put in blank in there, then we should get item creation error, blank name. And that was an object, so there aren't any parameters. Check that. That seems to have failed. Why is that? Because we still had this -1 in here, and that is the test that it's doing first, it turns out. Okay, this is beginning to come together. And we now have a way of forcing failures so that we can check other code in this persisting. On which subject? So we're going to now drill down and find other ways that this could fail. But before we do, I think we're doing the mapping here, but we could do it a little bit earlier. So this to item here, we're currently returning an item, but we could map the failure in here. We just go and take the code that we had up here, which is couldn't create item, put it into here, And now this will be not item creation error, but stock list loading error, which is nicer. And that means that up here, we don't have to map the items. So here we can just return it. Okay, so now we're going to go on hunt for other ways this can fail. And we can either guess or we can have a look at our code. And having a look at our code is a good way. So in here, we can see that we could not have enough tabs, basically. We could fail to split, and we could fail to convert to a local date, and we could fail to convert to int. So let's pick the first one of those first. And that is that we need there to be 3 parts: name, sell by date, and quality. Sell by date may be blank, but there still has to be 3 parts when we split this. So let's go off to our tests. So this would be too few fields. And so if we would put in something that only had banana, let's see how that fails first of all. We probably expect this to throw an exception. And lo and behold, it does. And what we might have expected, index out of bounds, because when we were over here, we were trying to do parts, I guess, 2, and it wasn't big enough. Okay, so let's head that off at the pass. We need a type for it. This is not enough fields. Now, what should we put in here? We could put the actual number of fields, but maybe more useful, and more useful in these other cases as well, would be the line that failed. So I think maybe here we'll just put line, which is a string, and we'll fix up the others to be the same in a minute. So we would like our test to fail with not enough fields. And the thing inside it should be the one that failed. Right, let's try that. We expect it to fail because we haven't put in the code to handle it. And it does. Back to persisting. And so in here, we're going to make an explicit check. So we're going to say that if parts dot size is less than 3, we're going to return a failure. And that failure is going to have inside it not enough fields. And that's going to have inside it the line that failed, which is sitting in this at the moment. Wonderful. Now, I think you're going to be a bit bored if I carry on doing all the others. So I think there's probably going to be a bit of fast forward happens around now. So to review, we now have a number of tests of what happens when things go wrong. We've got no quality, duff quality, too few fields. Oh, actually, I've missed one out. Okay. So, number of tests to show what goes wrong. And we have, I think, probably covered all the ways that this can fail. And if we're wrong, of course, then we will find out at runtime with some sort of exception. And if we keep looking at logs, we might see those. It's worth noting here this result of local date question mark. So in this case, we're saying if it succeeds, we may or may not have a local date. It's valid to have a null there because it was blank. That's a thing that we haven't done up here. What we should really have here is instant question mark and couldn't pass last modified. Let's just see if we can fix that up. What we want is that all this was null. then we want a success null in here. See what that does up here. And that's just saying, well, now that can't be null. So we can do that. Nice little tidy. Now, if you're a dyed-in-the-wool functional programmer, or in fact, even if you're just a little bit sensitive, you might be a little bit wary of these two returns. This one in particular is a little bit horrible because we're mapping through a set of lines, and then if any of them fails, then we are returning from this function. I don't know of a better way of doing this at the moment. We could do the map and then we could have a look inside to see whether anything is a failure, but in which case we're just going to be returning. So I don't like this, but it's the best of the worst of something. Here, however, we can do better. So this last modified is a result, and then we're unwrapping the result and saying we can use it here. And it's not a result because on failure unwraps, because it knows that if it was a failure, it's just going to return here. This in functional programming terms is just a map. And we can see that by taking this out of here and calling map on our result. We do that, and then, as we have done sometimes with lets, create a variable inside that has the same name as a variable outside. Then we can put that in there. Now, we can remove this in favor of the return and remove that. And now, because this is a map, we don't have to create the success in here. The map will do it for us. So what this is saying is, if this last modified from header succeeded, then unwrap the result, put it inside this block, and I will create a success of whatever you return from this block. Otherwise here, we will return the failure that this was. And so that's why we don't have to do this on failure on the outside. That's what map does for us. So that's a lot cleaner. We've still got this nastiness that we're going to ignore, but that passes. I think that's a good place to check in. And so this is now not result of item creation error, but result of stock list loading error. Commit that. Always with the warnings. There's one. Oh, and our other is not being used. That we can get rid of. Commit. Okay, I think there's one last place that we have an issue here, and that is this file load items. Now we know that use lines can throw. We only know it because it's doing I/O. It doesn't actually tell us. But I think it would be sensible to say that we'd like to wrap that up in our error type as well. So what we'll do is we will create one more. We'll just call it I/O. And we'll use the message that we get from any I/O exception. And now we've got one of those. This would be difficult to test without trying to build something that we then couldn't read from. I suppose we could do that. But I think probably we will just write the code in here a little bit untested. So we're going to catch any I/O exceptions. And if we get one, then we will return a failure with an I/O with the X message. And as that's nullable. And in fact, we don't need to put the return in there because this is a single expression. Okay then. So yes, that is untested, but so was the exceptions will be thrown anyway. I think it's probably safe enough. So with the exception of save to, which isn't part of our loading trail, I think we are probably done now for the things that can go wrong in persisting. So one last check-in. I think maybe we'll just make that an amend and we're done. So what's next? Well, that's the callers of file load items. That's the entry point to here. And that ultimately is our stock list load. At the moment, this is still returning effectively a nullable. And we have been able to make a change because we're just recovering by returning a failure of null here. Next time, then we will address that, pushing our error type up another one, and try and do something about the horribleness that is this code. And there's a whole bunch of places inside here, save to, create temp file, rename, and so on, all of which could be failing, that we would like to make better. If you'd like to see that episode, then please subscribe to the channel. You could press like to encourage me to do more of this. And if you have enjoyed this, then you'll probably enjoy the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook. In there, we cover a lot of error handling, refactoring from Java exceptions to Kotlin. Kotlin doesn't have the checked exceptions from Java, so these sort of techniques using error types are even more important to us if we do want our code to communicate the ways in which it can fail. Thank you for watching.